In this video we shall discuss transactions. In databases, a transaction is a set of operations that forms an inseparable unit. It is either all operations are successfully completed or all operations are cancelled if at least one of operation has failed. This is how it looks in details. Imagine we have two clients working with the same account. So the first client reads the account value, decreases it by some other value, saves the new value, then the destination account should be updated, but some error occurs here. So all the operations are cancelled and the database returns to the situation it has before the whole transaction has begun. But remember, we have the second client working with the same account simultaneously with the first client. The second client also reads the value of that account, decreases it, but he cannot save the value because the first client is working with that account. So the second client waits, and only when the first client has completed his work, no matter successfully or with failure, this account is now released, so the second client may update it and proceed with his work. We see that there is no error with the work of the second client, so the database comes to the new state, to the new situation. Here everything is saved and here everything is cancelled. It's obvious from the definition and the schema we just reviewed that transactions follow some principles. Atomicity principle tells us that no operations may be completed or cancelled on their own, so the transaction is a set of operations and either all the set is completed or all the set is cancelled. Consistency principle tells us that final transaction results may not violate database consistency. While some intermediate results may violate the database consistency, the final result of transaction may not. Isolation principle tells us that transactions may not ruin each other's work. Remember that example we've seen a couple of seconds ago. We had the first and the second client, and the second client was waiting for the first to complete his operations. And durability principle tells us that once transaction is committed, nothing will disappear. So when we have a lot of operations inside the transaction and the transaction is committed, none of those operations will somehow disappear. They all have some effect on the database. And the isolation principle needs some more explanations. All databases have transaction isolation level, a value showing the degree of visibility of changes between transactions. This is how it looks like. We shall start with potential problems description, and the first problem is lost update. It happens when two transactions are working simultaneously and the first transaction updates some information, then it is finished, and only then the second transaction updates the same data. So a transactions to update was later and changes from transaction 1, those changes were lost. This is the lost update. Dirty read happens when also two transactions are working simultaneously and the first transaction changes something and then it rolls back, so these changes are temporary. But the second transaction doesn't know that these changes are temporary. It reads some information and it reads only dirty data that will never be saved in the database. Non-repeatable read happens when one transaction reads something in the beginning and reads something in the end, and that results do not match. They do not match because other transaction changes some value of some data. This is the crucial to understand. It only changes the value, not the amount of data, unlike in the next problem. So here is this next problem. Phantom reads. The situation is the next. One transaction reads something in the beginning and reads something in the end, and once again those results do not match. But they do not match because other transaction inserts something or deletes something. So here we have the situation when amount of data changes, not the value like in the previous problem, but the amount. To deal with all these problems, we have transaction isolation levels. Here they are. This information is just a kind of cheat sheet, so you may pause the video and read the information about which isolation level protects us from which problem. And in a couple of seconds we'll see how to manipulate the transaction isolation levels. But first we have to review the overall transaction manipulation syntax. Each transaction should start with start transaction or begin transaction keyword in some DBMS, then the operations of transaction will happen, and then we shall use either commit transaction or rollback transaction syntax. This is how it looks like. We start transaction, we perform several operations, and then we either commit or roll back the transaction if some error occurs. And this is how we may manipulate transaction isolation level. We use the following syntax: set transaction isolation level, and here is the level name. In this first example we use fast but maybe inaccurate operation for data access, so we use the lowest isolation level possible, read uncommitted. Here we use slow but accurate operation. We use the highest possible isolation level, serializable. But of course we may just execute those queries without this transaction syntax, relying on default isolation levels and implicit transactions, because each and every DBMS has so-called implicit transactions. And you may rely on those implicit transactions unless your DBMS has a lot of connections, a lot of concurrency, a lot of users working with the same data at the same time. Now we shall switch to MySQL Workbench and see how these queries work. As long as transactions are database processes, not objects, we cannot see them in SPARX Enterprise Architect, they do not exist there, and even in MySQL Workbench we cannot see the transactions with our eyes. This is an internal process, it takes place inside DBMS, but nevertheless we may execute such queries and see that those queries are executed successfully. In the first query we've executed it with the lowest isolation level possible, and this query we shall execute with the highest isolation level possible. And we'll see, yes, it works. And once again the reminder, each DBMS has default predefined transaction isolation level, and it has implicit transactions, so you may just execute your query and it works here, and here it works also. We see it. So unless you have a highly loaded DBMS, highly loaded database with a lot of connections, with a lot of concurrency, with a lot of users, you may rely on implicit transactions and the default isolation level for each DBMS. So that's all about database objects and processes.